So now we're going to learn how to add fractions together. How would you add 1 over 10 and 5 over 18? Well, before you can add these fractions together, it's important to convert every one of these fractions into equivalent fractions that have the same denominator. So which denominator should you choose as the common one between these two fractions? Well, a natural choice is to choose the least common denominator, or the lowest common denominator. So use any viable method to find the least common denominator. You could, for instance, use prime factorization, or you could find the greatest common factor and then multiply these two together and divide by the greatest common factor. Or you could use some sort of table method. It doesn't really matter. In this particular case, I'm just going to use prime factorization. So let's start with 10. 10. And then try to find out if 10 is divided by 2, where 2 is the first prime number. And 10 being an even number is of course divisible by 2. So it's divisible by 2. And if you divide 10 by 2, you're going to have 5 left over. And 5 is also a prime number, so the prime factorization of 10 is 2 times 5. Now let's have a look at the second denominator, 18. Well, 18 is also an even number, so it will be divisible by 2. And you're going to have 18 divided by 2, 9 left over. And 9 is still not a prime number, but 9 is just 3 times 3, and 3 is a prime number, so 2 times 3 times 3 is the prime factorization of 18. 2 times 3 times 3 is the prime factorization of 18. So what is our least or lowest common denominator? Well, our least or lowest common denominator is going to be that denominator which has the highest combination of powers for every one of the numbers that you see here. So 2 appears with power 1 in this prime factorization. It only appears once in this prime factorization. 2 also appears just once in this prime factorization, so we're going to have a 2. Now what about 3? 3 does not appear in this prime factorization, but 3 appears twice in this prime factorization, so we're going to have times 3 times 3. What about 5? Well, 5 appears in this prime factorization, but 5 does not appear in this prime factorization. Take the greatest number of times that 5 appears, you're going to get 5. So what is this value? Well, 2 times 3 is just 6, so you have 6. And then 3 times 5 is equal to 15, so times 15. And then 6 times 15 is just equal to 90. So your least or lowest common denominator is going to be 90. So let's go back to our original problem here. We're trying to add 1 over 10 and 5 over 18. And I'm claiming that we should be converting 1 over 10 and 5 over 18 into equivalent fractions that have a denominator of 90. So how are we going to do that? Let me just rewrite our problem down here. So we're going to add 1 over 10 and 5 over 18. And so for the first one, for 1 over 10, if we want to convert this to an equivalent fraction that has a least or lowest common denominator of 90, we're going to have to multiply the numerator and the denominator by some number such that the resulting denominator will be equal to 90. So take 90 and divide it by 10. 90 divided by 10 is equal to 9. That means that we have to multiply the numerator and the denominator by 9 in order to get an equivalent fraction. So the top line, this line up here, 1 over 10 plus 5 over 18, is equal to 1 over 10 times 9 over 9. Because if we multiply the denominators 10 times 9, we're going to get a denominator of 90, and multiplying by 9 over 9 is the same thing as multiplying by 1. It's like we're multiplying this 1 over 10 by 1, because 9 over 9, this whole thing over here, everything we have here in the brackets is equal to 1. And any number multiplied by 1 is just equal to itself. And to this, we're going to add 5 over 18. But we also have to convert 5 over 18 into an equivalent fraction that has a denominator of 90. A denominator of 90, because 90 is our least or lowest common denominator. So how are we going to do that? Well, what is 90 divided by 18? 90 divided by 18 is equal to 5. So we're going to have to multiply the numerator and the denominator by 5. Because 18 times 5 will give us 90. And again, 5 over 5 is equal to 1, because any number over itself, any number divided by itself, is just equal to 1. And 5 over 18 times 1 is still equal to 5 over 18. So I hope it's obvious that this line over here, 1 over 10 plus 5 over 18, is equal to the line that is underneath, 1 over 10 times 1 plus 5 over 18 times 1, because any number times 1 is just equal to itself. So now let's just perform the multiplication. So we're going to have 1 times 9, which is just equal to 9. And then 10 times 9 is going to be equal to 90, our least or lowest common denominator that we found using prime factorization up here. And to this, we're going to add 5 times 5 is equal to 25. And 18 times 5 is equal to 90. So now we can combine these two fractions. Whenever you have two fractions that are being added or subtracted and they have the same denominator, you can just add the numerators together. So basically, this line above is equivalent to having 9 plus 25 over 90. Whenever you're adding or subtracting two numbers that have the same denominator, you can essentially put them both under the same denominator and keep the addition or the negative or the subtraction sign in the numerator, as we've done over here. Right, so now let's just perform the addition up here. So 9 plus 25 is equal to 34 over 90. Now we're almost done here, except that we can reduce this fraction. And we can reduce this fraction because we can take out a 2 from the top and a 2 from the bottom. So we can divide the numerator by 2 and we can divide the denominator by 2, because the numerator is an even number and the denominator is an even number. So what's 34 divided by 2? 34 divided by 2 is equal to 17. And what's the denominator divided by 2? Well, 90 divided by 2 is just equal to 45. And that's your final answer.